Okay, I am Shant Piratna from IT Center. As you know, this is ICT 1001 Information and Communication Technology course, right? So actually, this course contains two main parts, right? That is theory lectures and the practical sessions, right? So this is the first module, uh, Introduction to IT or Information and Communication Technology, right? Okay, the first one is what is data and what is information, and what is the difference between data and information. Simply, so data can be defined as a raw facts, right? So we call data raw facts, right? So data can be represented using characters like alphabets, digits, say 0 to 9, or using special characters like this, right? So what is information? Information is the process data, right? So information is the process data on which decision and actions are based, right? So by using informations, we can take some decisions and actions, right? So information has some meaningful values to the receiver, right? So the basic property of the information is a meaningful value, right? So data and informations are relative to the source, right? So that means if you say a particular thing is data, right? So the same thing can be information with respect to the source, right? So for example, if you say marks for the ICT course or ICT subject, so simply that is data. But the point of the lecturer, right? So with respect to the lecturer or the examiner, right? So what he or she has to do, she or he has to do some process to create marks, right? So they have to evaluate the paper. Then only they can have final marks. So with respect to the examiner, marks is information. With respect to the student, that is data, right? Because he or she actually he or she has to what you call answer for the questions, but he or she is not doing processed to uh, create the marks, right? So data and informations are relative to the source, right? Okay, so data is raw facts, so data are raw facts. The information is processed data. So that's the summary. Okay, then how to store data in a computer, right? So computers store data in the form of bits, right? So bits are usually we call 0 and 1, right? So bits mean actually binary digits. So you know binary number system. In binary number system, we have two symbols, 0 and 1. So we call those binary digits in computer. Then in computer, data is in the form bits, all right? So both 0 and 1 represent voltage level, all right? So usually 0 represent using 0 voltage and 1 represent in say 5 voltage, likewise, right? So in human readable way, it can be referred as files. So computer use a binary language, but which is not readable to the human being. So therefore, in human readable way, it can be referred as files, right? So many file types formats are there, right? So you know there are number of file types and formats, right? Actually, a file format is a standard way that information is encoded for storage in a computer file, right? So for example, if it is text file, there are so many file types, right? DOC or DOCX, TXT, likewise. Data files, you may have a DAT file, XML file, CSV files, so likewise. So there are a number of file types and file extensions, raw file formats, right? So you know these file types in computer, right? And then next one is what is computing, right? So how can we define the term called computing? Actually, if there is any goal-oriented activity with data are called computing, right? So if there is a particular goal and then there are some activities with data, then we call computing. Any goal-oriented activity with data are called computing, right? So in that activities, right? So we have to design, building, processing, structuring, managing various kind of informations, right? So that is computing. The next one is what is computer? What is computer, right? Think all of you have some idea about computer, right? But if you ask to define the term the computer, the device computer, so this is how we can define it. Computer is an electronic device that manipulate information or data according to the a set of instruction, right? So that is without the set of instructions, computer cannot do anything, right? So basically those instruction or set of instructions are called a program, right? A program, right? Usually we call program, right? So depending on the program, right? So or the according to the program, computer can manipulate the information, and then there is electronic device, right? So you have to highlight these 3 points when you define the term computer, which is electronic device, and this is the process that is manipulating information according to the set of instruction. Then we call set of instructions uh, is program, right? So that is computer has the ability to retrieve, process, and store the data, right? So here we can summarize that uh, points like this, right? So there should be an input, that's we call retrieve data, right? Then the computer can process those data, right, according to the set of instruction. Then set of instructions are called program, right? Then those information, that is the processed data, can be output or store inside the computer storage devices, right? Later on we can discuss computer storage devices, right? Okay. The next one is computer system, right? Actually, computer system can be categorized into three main sections. Those are hardware, software, and liveware, right? So let's take one by one, right? What is hardware? Actually, a hardware is a physical components of our computer, such as a system unit, a mouse, keyboard. So those are referred as hardware, right? So basically hardware means what is tangible, right? So this is the basic property of the hardware, that is we can touch it, right? So so that is something that can be touched and felt, right? So that is what we call tangible, right? So so these are hardware, right? So power supply, system fan, the motherboard, processor, RAM, right? So those are called hardware. And the next one is software. What is software? So software is a collection of executable programs with a proper documentation and configuration files, right? So what is program? So I told you that the program means a set of instruction, right? So actually the computer process data according to the set of instructions. So set of instructions are called program, right? So software is a collection of executable programs with a proper documentation. So that is documentation should be there. So software is collection of executable programs with proper documentation and configuration files, right? So that is software. So without software, computer cannot do anything. So by using the computer, using the software that makes the computer work. So software is the executing element of the computer. So without software, the computer cannot do anything. So basically, the softwares are stored in a secondary storage devices, right? So let's discuss storage devices later, right? So usually software held secondary storages, right? So the software loaded into the main memory. So basically we use RAM as a main memory. So software loaded or copied into the RAM as when executing time, right? So during the executing time, the software are loaded into the main memory, right? So when it is required, those software are loaded into the main memory of our computer, right? So the main property of the software compared to the hardware is software are intangible, right? So that is the opposite of the hardware. That is, we cannot be touch, we cannot touch and feel, right? So those are intangible, right? So we know there are a number of software, right? So actually at the end of this lecture, we can discuss the software types, right? Okay. And the next one is liveware. So liveware means the people using computers. That means the person who use the computer referred as a liveware, right? So based on the need for a human or liveware or to operate the system using hardware software, right? So without liveware, computer cannot be operated, right? Like this, right? So liveware means the people who use the computer, right? Okay. The next one is what is information and communication technology. So what is information and communication technology or ICT? So use of computer system for storing, retrieving and sending information, we call that is information and communication technologies there, right? Okay. The next one is main parts of the computer, right? So you know these parts, right? So I'm not going to describe one by one, right? So this is system unit, right? And then this is monitor, the keyboard is there, and then pointing device, mouse, and then sometimes you may have external uh, flash memory card reader, right? And then microphone will be there, right? Mic, and then some speakers may be there, printer is there, right? So likewise, so there are number of parts of the computer, right? Just you can refer this material, right? Okay. And then so this is the main part of the this lecture, that is the architecture of the CPU, architecture of central processing unit, right? So actually in central processing unit there are three main components. We call a control unit, ALU or arithmetic logic unit, and registers, right? Control unit, ALU and registers, right? And then you may have another memory, right? So we call that is main memory, right? And then the input and output devices are connected to the CPU, right? Input device usually we uh, connected using this arrowhead into the CPU, and then the arrowhead to the output device is actually like into this direction, that is out the information from the computer or the processing unit, right? Okay, let's take one by one, right? The CPU is actually the brain inside the computer. So that is the brain inside the computer, central processing unit. And the main components of the CPU is, so you know, control unit, ALU and registers. So the purpose of the control unit is direct the operation of the processor, right? The control unit control the operation of the processor, right? And then in addition to that, the control unit control the communication and coordination between input output devices, right? So control the communication and coordination between input output devices, that is now this is the time to input data, this is the time to output data. Likewise, they control the communication between input and output devices, right? In addition to that, they direct the control unit direct the operation of the processor, right? Okay. And basically we can say it coordinate the fetch, decode, execute cycle of each instruction, right? So there's a cycle called fetch, decode, and execute, right? So this is controlled by, or the coordinates by the control units. And then next one is arithmetic logic unit. Let's see what is the purpose of arithmetic logic unit, or we call ALU. Actually, ALU is a digital circuit that perform integer arithmetic and logical operations, right? So ALU is a digital circuit that perform arithmetic and logical operations, right? So arithmetic operations are, say, addition, division, likewise those are arithmetic operations. So what are the logical operations? You may heard that there are operations called AND, OR, right, and XOR. Likewise there are some logical operations, right? Okay, so that's about the ALU, or arithmetic logic unit, right? And the next part is registers. Now we know there are three main components: control unit, ALU, and registers, right? So we have already discussed the main two parts, ALU and the control unit. The rest one is registers. So registers are the small amount of memory associated with the processor or central processing unit, right? So it used to store data to be operated, right? So basically registers are used to store data to be operated, and it also access and use the main memory, right, with your computer, right? So it also access, that is, registers access the main memory of the computer. So basically we use RAM as the main memory in our computers, right? So this processor, or the central processing unit, and the main memory are linked together by buses, right? So main memory and the central processing unit link together by buses. So buses contains a set of parallel electrical conducting lines, right? So buses means a set of parallel electrical conducting lines. So I told you that the control unit coordinate the fetch, decode, execution life cycle. So what is fetch, decode, execution life cycle? Let's see. Okay, first one is fetch. So what is meant by fetch, right? So fetching means control unit loads the instruction or the next instruction to be executed, right? The fetching means the instruction uh, loads the instruction to be executed, right? Fetch it, and then at the same time we have to load data elements from the main memory to the register, right? So the fetching phase, control unit load next instruction to be executed, and the data elements from the RAM to the registers, right? So for example, so if you take a simple say operation, let's take, say, 10 plus 15, 10 plus 15. So in here both these 10 and 15s, so these 10 and 15s are called data. So this is data, right? So this is the instruction. So these are two instructions, that is addition and assign this answer to, say, particular variables called a. So these are data elements. So these are data elements. So these are operations. So these are data element. So these are called operations. These are operations, right? That is take the addition and assign to the another memory location, right? So control unit loads the next instruction to be executed, and the data element from the main memory to the register. So that's what we call fetch. And then decode. So what's meant by decoding, right? So decoding. So even this is operation. So these are not keep or the stored in the main memory as it is, right? So these are these operations. Let's take addition, right? The addition. So there are a set of, or the binary number sequence. So let's see, a binary number sequence is like this. So this is addition, right? So basically in this fetching phase, the control unit load the next instruction to be executed. It is something like this, right? So actually the processor don't know what is this instruction. Then the decoding phase, control unit interpret the instruction and find out what to do, right? Decoding means control unit interpret, right? They understand or they interpret what is this operation. This is adding, right? Or in other case, that means maybe say multiplication. Likewise, they interpret the operation. Say they interpret the instruction and finds what to do, right? In execution phase, they execute this instruction according to the interpretation, right? So in execution, that is control unit send the relevant signal to the ALU, right? Arithmetic logic unit to perform the operation, right? Execution means control unit send the relevant signal depending on this interpretation of the decoding phase. They send the relevant signal to the ALU to perform the operation. So that's what we call execution, right? And ALU perform the operation on stored data in registers and store the result back in the register, right? So depending on the operation, ALU perform that operation and store the data in registers and the stores the result or the information back into the register, right? So that's what we call execution, right? In execution phase, ALU perform the operation, right? So that's it, right? So you must have a basic idea about this fetch, decode, execution cycle. Fetch, decode, execution cycle, right? So fetching means load the instruction to be executed and load the data. Decoding means interpret this instruction, that is what to do, right? In execution means uh, uh, control unit send the relevant signal depending on this instruction to the ALU so that ALU can perform the operation. Then the ALU perform the operation over the data which are in registers and send the information or the result back into the registers. And later on, those results transferred to the main memory, and then those results can be stored in a secondary storage as a files or put into the uh, output device like monitor. Okay, so that's the basic idea behind the fetch, decode, execution cycle, right? Okay, then let's say finally control unit copy the result back into the RAM, right? Okay, so that's about the fetch, decode, execution cycle. Okay, next one is system bus. All right, so I told you that control the what you call central processing unit and the main memory link with buses. All right, so there's a bus called system bus. Right, according to the von Neumann architecture, there are three buses are used to communicate between control, central processing unit, and devices. Right, so those are control bus, address bus, and data bus. Right, control bus, address bus, and data bus, like this. All right, so the central processing unit link with the main memory using these buses. In addition to that, the central processing unit link with the input output devices, right, through these buses, right? Control bus, address bus, and data bus. All right. Okay, next one is actually that is the basic idea about the architecture of our computer, right? And next one is types of computers. All right, there are several types: mainframe computer, supercomputer, personal computer, and then laptop computers or laptop embedded computers, right? So these are the main computer types that we have. Okay, let's take one by one. The mainframe computer. So these are very big computers which we have several decades ago, right? So there are powerful, expensive computers used in the background by most large organizations, right? So actually, these computers are used by the large organizations, right? Like this, right? then supercomputers. Actually, an extremely fast computer which can perform thousands or the millions of instructions per second. Supercomputer means a computer which can perform a thousand or the million number of instructions per second, right? So these are used by military purpose, so space traveling or weather forecasting purposes, right? And the basic idea of supercomputing is a computation by many processors on a common task, right? That is the uh, if there's a particular task, the task is assigned to the a number of processors, right? So this is similar to situation where many people cooperate to accomplish a task which is impossible for one person to do it, right? That is, if there is a one particular task, right? So instead of assign one person to do that, so we can assign a number of people to do that same task, right? Okay, all right. So these are the supercomputers. And then next one is personal computer, or we call PCs, right? So these are the relatively inexpensive computer designed for individual users, right? So you know these things, right? So I'm not going to explain uh, more details in here, right? Actually, in IBM invent the PC the way back at say 1981, right? So this is called personal computer. And then next one is laptop and farm top computers, right? So these are the main feature of this laptop is the portability, right? So portable, that means we can bring in the remote areas and then work with the laptops, right? And then the another the basic feature is it can run on batteries as well as main power, right? So that means it don't have a power supply, right? So without power supply we can work with the battery, right? Okay, so they are special they use special screens rather than the traditional uh, screen, right? So the phantom computer are even smaller than the laptop computers, right? So you know these things, right? And then next one is embedded computers, right? So what's meant by embedded computers? All right, so embedded computer means the computers that are dedicated to perform a specific task, right? So the computer that are dedicated, right, to perform a special task, right? So it may be a washing machine, or it may be a say air conditioner, or it may be a modern vehicle, right? So in that systems, so inside those systems there are some units which are dedicated to perform specific tasks, right? So for example, in modern vehicles, right? So there is a special electronic unit for brake system, ABS, right? So that is designed for perform a specific task, all right. So in a modern washing machine there are some special units which is control the say the power of the washing machine and then the speed of the that what do you call that rotations, all those things controlled by the particular unit, right? So that unit is called embedded unit or embedded computer. That is, that unit is dedicated to perform a special task, right? Okay, and then we come to the computer storages. So first one is a memory unit. What is memory unit? Actually, a memory unit means a amount of data that can be stored in a storage unit, right? Amount of data that can be stored in the storage unit. So the storage capacity are expressed in terms of bytes, right? The storage capacity are expressed in terms of bytes. So what is byte or what is a bit? First one is bit. Bit means a binary digit. Binary digit. So we know in binary number system we have two symbols or two digits, 0 and 1, right? So this is a binary digit. right? So binary digit. So simply we take B from binary, IT from digits, then we call this is digit, one digit, right? Okay, the representing a passive or active state of a computer in an electric circuit, right? So these digits are represent using electrical uh, voltage actually, right? Okay, so the smallest measuring size is bit. All right, in memory units, the smallest measuring size is bit. All right, so this is how we go it, right? So 8 bits called 1 byte. That means any number of here may have any number of bits, but if you take a 4 into 2, that is 8 bits, right? 8 bit, then we call this is 1 byte, right? So this can be 0 1 1 0, right? 1 1 likewise, right? So this is in here we have 8 bits, then we call this is 1 byte, 1 byte, right? This is 1 byte, 1 byte. So 8 bits we call 1 byte, then 1024 bytes. 1024 means actually 2 to the power 10, 2 to the power 10. Then 2 to the power 10 bytes we call 1 kilobyte, 1 kilobyte, KB, right? Then another 1024 kilobytes we call 1 megabyte. Then 1024 megabyte we call 1 gigabyte. 1024 gigabyte we call 1 terabyte. Then 1024 terabyte equal to 1 petabyte, right? Then you must have ability to convert the byte into bits or bytes into kilobytes or megabyte likewise. So I'll take example. Let's take say 4 GB, 4 GB. You may have seen this 4 GB, 4 GB RAM likewise, right? So in 4 GB, how many bytes are there, right? So you know 4 is 4 GB. GB means so gigabyte. So 1 gigabyte equals say 1024 megabytes. Right? So 1024 megabytes. Right? Okay, then 4 into 1024. So 1 megabyte equal another 1024 kilobytes, KB, KB. Then 1 KB equal 1024 bytes. All right, so 24 here, 1024. So 1 kilobyte, right? So 1 kilobyte equal another 1024 bytes, 1024 bytes, like this, bytes. Then 4 means, so simply we can say 4 means 2 to the power 2. Here 1024 means 2 to the power 10. Here 1024 means 2 to the power 10. Here 1024 means 2 to the power 10. Right, so these are bytes. These are bytes, right? So all together you can say here 2 to the power 10, here 2 to the power 10, here 2 to the power 10, right? So this according to the same base of the integers we can take the summation of these powers. Then 2 plus 10 plus 10 plus 10, that is 2 to the power 32, 2 to the power 32 bytes, right? So that is a 4 GB memory. In terms of bytes we can say 2 to the power 32, right? 2 to the power 32. If you want, you can convert it to the bits because one byte means 8 bits. If you multiply this one by 8, then that number of bits are there. So likewise, we can convert any memory unit into the smallest unit of the memory unit, right? Like we can convert memory units, right? Okay, so that's about the memory unit, right? Okay, and the next one is hierarchy of the storage. Hierarchy of the storage. So this is the hierarchy. Primary storage. So what's meant by primary storage? Primary storage means are directly accessible to the central processing unit. There is a storage which are directly accessible, right, to the CPU. We call those are primary storages. For example, main memory. So main memory can be directly accessed by the central processing unit. All right. Secondary storage. Secondary storage means that those are not directly accessible by the CPU or the processing unit. All right. So, for example, hard disk. Right. And then thirdly, storage. Thirdly means it involves a robotic mechanism to mount and dismount removable mass storage. For example, our flash drive, the pen drive, right? They use some kind of say we call plug and play devices, right? So we can mount as you wish, and then we, if it is not used, we can dismount it. All right. And the next one is offline storage. That means if you have some documents, we can get a printouts uh, and then keep on another location, right? Those are offline storages, right? Those are called offline storages, right? And then next one is what are the main characteristics of memory, right? The characteristics of memory. Okay, in here actually we have to discuss two main characteristics, right? So the first one is volatile memory, volatile. So volatile means it requires a constant power to maintain stored information, right? So if it is required a constant power to maintain the stored information, we call that is volatile memory, right? So that means if it is if there is no a constant power supply, right, then they lost the memory, right? It is lost its data when the power of the computer or the computer is turned off, right? So without constant power supply, they can't maintain stored information, right? So that's what we call volatile. Then the fastest memory technologies of today are volatile memory storages, right? So that means they need a constant power supply to maintain uh, stored data or information, right? So for example, RAM is volatile memory, right? And the next one is non-volatile memory, right? Non-volatile memory. Non-volatile memory means it will retain the stored information even if it is not constantly supplied uh, electrical power, right? That means it is not required constant power supply to maintain a stored information. It is not required, right? So it is suitable for long-term storage of information, right? So the non-volatile memory is suitable for long-term storage of information, right? So for example, hard disk, right? So hard disk is non-volatile memory storages, right? Okay, those are the two main characteristics of memory: volatile memory and non-volatile memory, right? Okay, and then next one is random access memory, right? So what is random access memory or RAM? Actually, RAM is the working memory of the computer, right? So RAM is the main working memory of the computer. So that is when booting the computer, operating system is loaded to the main memory or to the RAM from the hard disk, right? So when you switch on the computer, so operating system is loaded to the RAM from the hard disk, all right? So without RAM, we can't work with the computer. That is, RAM is the execution memory. That is, if you open particular application, that application is loaded to the main memory, right? So that application is loaded to the main memory. Usually applications are held on secondary storage devices. So usually in computer, applications are stored in a hard disk. And then when you open that application or when you access the application, that application is loaded to the main memory or RAM from the hard disk, right? Okay. The next one is read-only memory, or we call ROM. What is ROM? Right? So ROM is a special type of memory, right? Actually, there is memory chip from which existing software can be read but not written with. Right? That means we can't written instruction to the read-only memory, but we can read instruction from the ROM. right? So there are special type of ROMs we call ROM BIOS chip and which contain read-only softwares, right? So ROM chip is programmed during the manufacturing time, right? So ROM chip is programmable during the manufacturing time, right? And the network cards and video cards also contains ROM chips, right? Okay, the ROM contains the program contain the basic functions that a computer should execute when the computer is started, right? So in ROM or the in BIOS ROM or the ROM contains the program, right? The basic functions, or we call basic input output system or BIOS, right? The basic functions that a computer should execute when the computer is started, right? So when you switch on the computer, basically operating system is held on the secondary storage device, that is hard disk, right? Then the operating system should be loaded into the main memory, right? So those instructions are available in these kind of ROM chips, right? Okay, that is the computer should execute when computer is started for the basic functions, right? Okay, and then this is the comparison between RAM and ROM. So RAM is temporary memory, right? So as I told earlier, that is volatile memory. That is a content are lost when power is off, right? So whereas ROM is permanent memory, that is non-volatile. That is non-volatile memory. That is the content are not erased or content not loose, right? That is not lost when power is off. So RAM is read and write memory. That means we can read the information in RAM and then we can read into the RAM, right? But the ROM is read-only memory, right? RAM is working memory. That is during the execution time, the data and information are loaded into RAM. But ROM is used to store startup instruction, right? Or we call booting instructions, right? How it is boot, how it is load the operating system from hard disk to main memory. Likewise, those instructions are stored in ROM, right? So the ROM used to store startup instructions, or we call boot up instructions, right? So if it is volatile, then what will happen? The computer cannot be started because we need constant power supply to maintain this information in ROM. But since this is non-volatile, these instructions are not lost even power is off. So that's the difference between RAM and ROM, right? Okay. And then next one is video memory. Video memory, or we call it graphics memory, right? So the picture that you see on your screen is a form of data, and this data has to be stored in somewhere or in a location, right? So the on-screen picture are held in special memory chips called video memory chips, right? So these pictures are held in a special memory chips called video memory chips, right? So these chips are usually located on video card, right? So these chips are usually located on the video card. A modern computer will be supplied with several megabytes of video memory, right? So this is a video card, right? So this is the sample of video card. Okay. And then next one is peripheral devices. What is peripheral devices? So any external object that provide input and output for the computer can be called as peripheral devices, right? Any external object which provide input and output for the computer, right? So there are three different types of peripherals. We call input, output, and storage, right? Input devices, output devices, and storage devices are main peripheral devices, right? Okay, let's take input, output, and storage devices, right? So before that, the first of all we consider the secondary storage devices. What are the secondary storage devices that we have, right? So actually, in earlier we discussed the hierarchy of storage devices, right? The primary storages and the secondary storage, ternary and offline. All right, so I recall it. Primary means any storage device which are directly accessible to the central processing unit. Secondary means the storage devices are which are not directly accessible to the CPU. All right. Okay, then the secondary storage devices can be categorized into several categories, right? So magnetic storage, actually the technology which is used in storage devices are key component to categorize these uh, categories, right? Okay, the magnetic storage devices, optical storage devices, the flash memory devices, online or cloud devices, storage devices, and the paper storages, right? So in magnetic category, we have floppy disk, hard disk, and super disk, right? Zip disk or the tape cassette, right? So those are belong to magnetic category. And in optical category, we have the CD, DVD, right? Blu-ray disc. Those are all are belong to optical category. And then in flash memory, we have say memory card, memory sticks, flash drives, all are belong to flash memory, right? And then online and cloud category, we have cloud storage, network media storage. So those are belong to online and cloud. In paper storage, you know, punch card technology and OMR technology, the technologies which are used in paper storages, right? So those are used in earlier, right? Okay, let's take some few storage devices, right? So I'm not going to explain in details, right? So you can get this information from this material on the notes, right? So I just explain these things, right? So because most of you know these things, right? In floppy disk, actually this is thin magnetic coated disk containing in a flexible or semi-rigid protective jacket, right? So in here, data are stored in tracks and sectors, right? Data is stored in tracks and sectors, all right? So I'll explain tracks and sectors later, right? So in here, a double slide high density or 3.5-inch, this can be called 1.44 megabytes of data, right? So small amount of data can be stored in floppy disk, right? So once the data is stored in a floppy disk, it can be write protected. So by clicking a tab on the disk, all right. So once if you store the data in floppy disk, we have some kind of what called a switch, right? So by using that switch, we can keep those data as write protected mode, all right. So this will prevent any new data being stored or any old data being erased, all right. So think you may have seen this kind of floppy disk, right? So in here we have a special kind of switch which can be used to uh, uh, use this write protected mode, right? Okay, so in here till yeah, in here you may have a switch, right? Here or there, right? So you can use that switch to keep your data as a write protected mode, right? Okay, next one is hard disk, right? So you know hard disk, that is this is uh, the what you call main storage in our computer, right? See in here there are some circles on the magnetized surface. The magnetic disk are known as tracks, all right? So the tracks on the disk surface are divided into invisible segments known as sectors, right? So each sector store a fixed amount of user accessible data, right? So usually 512 bytes for hard drives, and then 2048 bytes for CD and DVD ROMs. All right. So yeah, this is the image. Right. So in here, right. So in hard disk, right. So if there is a one surface, right. So we can identify a number of tracks. All right. So these are called tracks. Right. These are called tracks. Right. Then one particular tracking is divided into these kind of sections we call sectors. All right, sectors. right? It says the track on the disk surface are divided into invisible segments known as sectors. So this is one track, right? So this is one particular track, right? So for example, this is a one track, right? So this is called track. So number of tracks are there, right? So this is a one track. Then in this track, the track is divided into this kind of segments. We call this segment a sector. This is another sector, right? Which is an outermost track, right? This is sector, all right? So we can use these sectors to store the data, right? So if you take one sector, right, so we can store this kind of data segments, right? So actually in data segments, so there are two main parts we call header and trailer, right? In header section we can have information which are used to synchronization, and in tail section we have another data we call error correcting code, right? So in between header and trailer section, actually, so this is the place where we can store the data, right? So the same technology is used in floppy disk as well, right? So this is the second technology used in magnetic disk, magnetic disk in our hard disk, all right? So actually, in hard drives, there are two technologies are used. So this is used in a magnetic, or that we call hard disk drive, and then in addition to that, there is another technology we call SSD, or we call solid state drive, right? And then we have hard drives as well, SSD and HDD, right? And SSD hard drives has no moving parts. Actually, in here we have moving parts. That means there's a moving head disk there, right? Like this, right? So this moving head disk, yeah. So this is we call translational into this direction, right to left, and then this hard disk rotate like this, right? So if you want to access this particular sector, right, so it will be rotate like this. Then when it's come to here, this segment, let's see this one, this sector can be accessed using this header, right, this header. So if you want to access this part, right? So then what we have to do, right? So this header should be, so this hard disk rotate into here, here. Then this section, right? So let's see this section. This section will come to here, right? Will come to here, and then this header should be moving to the left direction, right? This header move into the left direction. Then when it come to this hard disk, this sector, or this segment come into here, when it's come to here, this by using this header it can be accessed. Assume now header is in here, header is in here. Then when this segment come into here, by using this header it can be accessed, right? Then this hard disk rotate into this direction, right? Let's say clockwise or anti-clockwise. In here we call clockwise direction. Hard disk rotate in clockwise direction. At the same time, this header can be rotate, can be what you call moving to right direction or left direction, right? So both movings are useful to for accessing data in hard disk, right? But in SSD hard drive, they don't have any moving parts, right? Then the less chance to breakage, right? At the same time, SSD hard drive use the flash memory, which can be store and access data much faster than HDD, right? So they don't have moving parts, therefore the power consumption is very low compared to the hard disk drive, right? And then this is easy to install in our computer, right? So that's about SSD technology, or solid state drive, right? Okay. So that's about the SSD versus HDDs, right? So in addition to that, we can compare the access time, right? So I told you that SSD is very faster than the HDD, right? So this is the access time, 0.1 millisecond. In here, it goes to 5.5 to 8.0, right? And then it says the random input output performance, right? So this is the performance in SSD. So this is the performance is HDD, right? So this is the comparison between SSD and hard disk drive, right? And then this is the CPU power needed to hard disk, right? So 7% needed in SSD and 1% in SSD CPU power, right? And then energy saving, right? It's a the SSD consume 2 to 5 watt, right? So at the same time, STD consume 6 to 15 watt, right? Because they have some moving parts, right? So I told you that hard disk drive moving at the same time that header is also moving, right? Then the reliability and the input output request time, right? And the backup rates, right? So we can compare these parameters in SSD and hard disk drive. Right. So, okay, that's about the comparison between SSD versus hard disk drive. Right. Okay. And the next one is magnetic tape. Magnetic tape. Actually, in here, the magnetically thin coated piece of plastic wrapped around wheels capable of storing data. Right. In magnetic tape, they use a thin coat piece of plastic, thick wrapped around wheels capable of storing data, right? So the tape is much less expensive than the other storage mediums, right? Some of you have may seen these magnetic tapes, right? In earlier we used this what you call that cassette tapes, right? So to storing musics, all right? So in those devices we use this magnetic tape technology, right? So it is much slower solution that was typically only used for backups, right? So nowadays we use these tapes for backups purposes, right? So these are those tapes, right? And then we come to the optical disc. Optical disc. So this is a metallic disc that use a laser beam for reading and writing purposes. All right. So in optical disc, we use a laser beam to reading and writing purpose. Right. So there are four kinds of optical disc. All right. So we call CD or compact disc read-only memory. Right. CD-ROM or a compact disc read-only memory. Right. So in here, we cannot be written on or erased by the user, right? So we can only read the data on CD-ROM. And the next one is CDR, or we call CD recordable, right? So we call write once, read many, right? So it can be written to one time only, but we can read many times, right? So after writing to the disk, it cannot be erased by user, but it can be read, right? It can be read many times without any problem, right? So erasable optical disk, that is, can be written and erased and reused, right? We call reusable disk, right? So the two basic types, ZDR or compact disk rewritable, or we call magnetic optical. So the next part is next type is DVD. All right, so this is similar to CDs but have a greater capacity of say 4.7 gigabytes. All right, so next one is Blu-ray disc. All right, so Blu-ray meet of the HD, DVD, high definition disc formats. All right, so this is the what you call the summary of this optical disc execution. Right, so they use laser beam to read and writing purposes. Right, okay, and then in here we have some we call a lands and the fits. Right, so these are called lands, and then we have fits. Right, so lands and fits actually they create these lands and fits using the laser beam, right? Okay, so that's about the optical disc. And the next one is flash drives or flash pen drives, right? So here we have very high capacity portable devices, and it can be plugged directly into the USB port, and the present the pen drives which are about thumb size have gigabytes of memory, right? So nowadays we have pen drives which are about thumb size, that is the very small in size, and then even it is small in size we have gigabytes of scale memory, right? Like this, right? So you know these things. And then next one is the memory card. Memory card. So this is the alternative referred to the flash memory card. And then used to store photo, videos, or the other data in electronic devices. All right, so this is image of memory card, right? The next one is the cloud computing, right? The cloud computing is very popular topic in nowadays, right? So in here, the services provided over network by a collection of remote servers, all right? In cloud computing, the services provide over a network by a collection of remote servers, right? So this is actually the abstract cloud of computer provide the massive distributed storage and processing power, right? So it can be accessed by any internet connected device running on a web browser, right? So that means, so I'll explain some little bit more than this node, right? So because nowadays this cloud computing is very popular, right? So actually in cloud computing we can divide into three main sections, right? So they provide application as services, platform as services, and infrastructure as services, right? So application as a services means in cloud services we have some applications, right? We can use those applications if you have internet connection. So for example, in nowadays we have a Google services, right? So in Google service we have a Google Docs, right? So we can use those Google Docs without any application installation in our local computer, right? So we don't need those applications. Those applications are stored or installed in the Google servers. We can use those applications if you have a Google account and the internet connection. Then we call that is application as a service, right? And next one is platform as a service. Platform as a service means there are some softwares or the databases. We can store our data in those databases. Actually, those databases are stored in not in our computer, right? Those are in a particular server, which is not in our area, right? Which is in a remote server, right? Which is in on a different location, right? So we can use those platforms. Platform means the operating system and the hardware system, right? So that basically we use some softwares, right? Softwares, but we use those systems to store our data, right? So those systems provide a platform. Then we call platform as a services, all right? So and the next one is infrastructure. Infrastructure means we can store or we can use uh, the cloud services as an infrastructure. Infrastructure. That means we can use the remote hard disk to store our data. In that case, we don't have an application. We don't provide the application by the cloud services. We are provide the storages. So Google Drive, we can store our documents, right? So in that case, we are provide the infrastructure. Infrastructure that is say hard disk, right? So we can store our data in Google Drive. So in that case, we call infrastructure as a service, right? So these are the main three services provided by the cloud computing: application as a services, platform as a services, and infrastructure as a services. Right? Sometimes you may ask what are the main services provided by the cloud computing, right? So first one is application as a services, second one is platform as a services, third one is infrastructure as a services, right? Okay, that's about the cloud computing. The next one is network storage media. Network storage media. Actually, media is any audio, video, images, or text used in a computer network, like the internet, like the internet. So it almost always requires a computer to send and receive, and a community of people to create and consume the content. And it says actually the storage is provided by the network. So that means we can store our data or the applications, basically data, in a network devices. All right. So we don't have a storages in our local computer. At the same time, we have some locations to store our data in our network, right? So that's what we call network storage media. Next one is optical mark reader, or we call OMR, optical mark reading. So in a process of gathering information from human beings by recognizing marks on document, right? So here can accomplish by using hardware device that detect reflection or limited light transmittance on or through pieces of paper, right? Like this. And the next one is punch card, right? So actually punch card containing several punch holes that were punched by hand or machine to represent data. So these cards allowed to store and access information by entering the card into the computer like this. So these are called punch card or the punch card machine. And then next one is a memory hierarchy. Memory hierarchy. So this is the memory hierarchy, right? So in bottom of the hierarchy we have offline storages, and then next to that we have a hard disk, right? And then we have a RAM, right? And then we have a cache also a memory storage in our processor, central processing unit. And then the topmost memory location, memory uh, storage is registers. So we call CPU registers, right? So when you go to the upwards, right? So speed of the memory storage is high than the lower one, right? So into this direction, the speed is high, right? So when you come to the uh, cost property, right? Cost, this is very expensive, right? Than the lower level storages, right? And then when you compare the size, right? So size is increased into the uh, downwards, right? That is the storages which are in the topmost of this triangle is very small than the other bottom layers, right? So here it is very small, 512. Here we may have 12 megabytes, right? And then here if it is a hard disk, or the sorry, the if it be RAM, right? So the so those are very high scales, right? So if it is hard disk, it may be 2 terabytes. If it is a RAM, it may be 8 gigabytes, right? So if it is a cache, that is say 12 megabytes, right? If it is CPU registers, maybe 512 bytes, right? So that's right. Uh, that's how the what you call size of the memory is changing in this hierarchy, right? That is when you come to the bottom, the size is very large. When you go to the upwards, the size is very small, right? So register is a part of CPU, right? So the cache is also available inside the CPU, right? And then RAM is associated with the central processing unit, but the hard disk and the other storages are not directly accessible to the central processing unit, right? So you must have an idea about this memory hierarchy, right? So how this speeds is change, right? So when you come to the upwards, how speed is change, whether it's increase or decrease. If you consider the cost, right? How this cost is changing, right? When you go to the upwards and downwards. When you compare the storage size, how it is change, right? So when you go to the downwards, storage is high. When you go to the upwards, storage is low. When you go to the upward, cost is high. When you come to the downwards, cost is low. When you go to the upward, the speed is high. When you go to the downwards, the speed is low. Likewise, you must have an idea about this memory hierarchy, right? Okay, the next one is actually the another picture of this memory hierarchy. So you can just refer this image, right? So just you can pause the video and then refer this image, right? So the CPU registers as the topmost memories hierarchy, right? So this is directly accessible to the CPU, right? CPU registers, cache memory, and the main memory, right? So all these are directly accessible to the CPU. And then the cache memory, RAM, right? So and then we have virtual memory and the physical RAM. So actually these are temporary storage areas, right? So that is these storage areas as working as executing memory storages, right? So once power is off, so all the data in this area will be erased or lost, all right? So this is the permanent storage area, right? So in here we have hard disk drive and then removable disk, ROM, BIOS, right? All are permanent storage areas or network storages, right? So these are not directly accessible to the CPU, right? And then the operating system also held in this secondary storage devices we call hard disk drive. And then in uh, bottom of this secondary storage devices we have input sources, all right? Maybe a mouse, keyboard, all are from bottom of this secondary storage device type, right? Okay, so that's about the memory hierarchy. That's about the memory hierarchy. Okay, and then next one is input devices. Input devices. So actually, you know what's meant by these input devices. Basically, we have any we call any device which can be used to input data to the computer. We call input devices, right? The first one is the mouse. Actually, mouse is we call a pointing device, right? So in terms of size, so this is the palm size device, right? So this is used to control the movement of the object on the computer screen. We call this cursor, right? So here we use the mouse as a pointing device, right? So here we use the mouse as a pointing device, right? So I can point a particular location of the screen, right? So basically we have a cursor or a pointer, right? So that's about the mouse, right? Okay, and then actually in here we have the I'm not going to explain much more, right? So left mouse button, right mouse button, and then the scroller is there, right? So in mouse we have say PS2 mouse and then USB type mouse. So this is USB type mouse, and at the same time we may have a mouse which is working using the Bluetooth, right? So likewise, so the mouse uh, now so the several what you call versions, so several types, right? Okay, and the touchpad is also acting as a pointing device. So this is for pointing on a computer display screen, right? So this is actually alternative to the mouse. So most of the time, so these touchpads are available in laptop computers, right? So this is originally incorporated in laptop computers, right? So this is also being made for use with desktop computers as well, right? So works by sensing the use of finger, right? So movement and downwards pressure, right? Okay, so this is touchpad. And the next one, keyboard. Actually, keyboard is the what you call the mainly used for entering information into the computer. So this is the most common way of entering information into the computer. So this is the main input device, and a number of different types of keyboards. So including those special design to use, say Microsoft Windows, right? So you normally we use this QWR ERT keyboards, right? Actually, yeah. So this is the what you call the order of this key range, right? QWERTY. So this is the arrangement of this key, right? So this one version, right? The most commonly used version. The name for our computer keyboard comes from the first six letters in the top of the alphabet row in keyboard, right? That is the arrangement of keys, right? Okay, so now this is the arrangement. So this is the arrangement of keys, right? So in here we can identify several uh, categories of keys. So this is alphanumeric keys, right? So this is the typing keys, and then here we can have say function keys, right? Function keys, and then so these are called control keys, and then these are called navigation keys. Navigation keys. Here we have a numeric number pad or a keypad, right? So likewise, keyboard can be grouped using these operations or the features of keys, right? Okay, and then next input device is scanner. Actually, a scanner is used to read text or images printed on a paper and translated the information into a form the computer can use, right? So, okay, so this is the what we call animation of how this printer is working, right? So this is the first scan image, all right? Okay, and the next one is a digital camera versus a webcam or the web camera. Actually, digital camera stores image digitally, and once the picture has been taken, it can be transferred to the computer system, and then we can edit using graphic softwares and print it. In webcam or the web camera, so this is the camera or the a video camera usually attached directly to the computer, right? So it can be also use text digital images and transmit them over the internet, right? And this is widely used for chatting through the internet and then to do the seminars, and nowadays we use this for this kind of technologies like Zoom, Microsoft Teams, likewise, right? So this is actually attached to the our computer, right? Okay, so the next one is microphone. You know, this is a device which convert the sound into the electric voltage waves or signals, all right? So this is also another input device, right? And the next one is output devices. What are the output devices that we have? The main output device is monitor, right? So actually monitor is visually interface with the computer. So mainly there are two types of monitors, right? CRT, LCD, and LED monitors. Actually, not the three types of monitors, all right? Sorry for that, all right? So here we have three type of monitors, right? So CRT, as LCD, and LED. Nowadays we use LED monitors, right? So in here, visual display unit, or we call VDU display, images and text, right? So those are the made of the small box of colored light called pixels, right? In monitor we have a small blocks of color light, color dots we call pixels, right? Actually the resolution of the screen improve as the number of pixels is increased, right? So if pixels or the number of pixels are increased, the resolution of the screen will be increased, right? So let's take these types of monitors, CRT monitors. So CRT means we call cathode ray tube, right? So this monitor tube is glass vacuum tube, and in one end we have an electron gun, and in the electron gun project three beams, RGB or the red, green, blue beams. So the display surface coated with phosphorus, and when the electron beams strike the coating, it goes it goes with the particular color like this, right? So this is the electron gun. This electron gun uh, here, this electron gun project the three beams, red, green, and blue, right? So this gun projected these electron beams into this kind of surface, right? Then it will produce a color dot, right? So depending on the what you call intensity of this red, green, and blue, it will produce a particular color, all right? Okay, so that's about the CRT monitors. So here we have cathode, in here we have conducting coatings, right? So B, right? So C is anode, right? So in here we have D, right? So in here we have phosphorus coated screen. So this is the screen, right? So these beams are projected to this screen, then it will produce a, particular dot or color dot. And then we have LCD monitors. So LCD standard for liquid crystal display. So this is used in digital vouchers and many portable computers, right? In here we have low power consumption when considering to the CRT monitors, and it also it has excellent text construct than the CRT, right? So in here, so by comparing to the CRT, the contrast is excellent in LCD monitors. right? So like this. And nowadays we have LED monitors, right? So an LED display is a flat panel display. So in here uses an array of LED or light emitting diodes as a pixel for video display. All right. So in here capable of providing general illumination in addition to visual display, right? So like this. So by comparing to the CRT, the power consumption is very low in LED monitors, right? And then next one is printers. Printers. Actually, there are several type of printers are there. The first one is we call inkjet printers. Inkjet printers, right? So in here, in inkjet printers, they tiny drops of ink onto the page to create an image. They are what you call dropped a tiny ink into the paper to produce image, right? So that's the technology in inkjet printers. So in here capable of providing high quality print which almost match the quality of the laser printer, right? I'll come to the laser printing later, right? And then it has a resolution of say 300 dots per inch, right? So this is the image of inkjet printers. So in here we have tiny drops of ink to produce image, right? And then next one is laser printer. In here, laser print is print very fast and the supply cartridge work a long time. And in here we have color laser printers use the same toner based printing as laser printers. So, but that they combine 4 different toner colors, right? Then the color laser printer can also be used as a regular black and white laser printers as well, right? So in here, the special thing is the what you call the quality of the printout is higher than the other printers, right? And then next one is impact printers, or we call dot matrix printers, right? So the earlier one, that is inject and the laser. In inject and laser, in inject printers, they drop tiny drops to using ink. In laser printer, they use laser beams to print. In impact printers use a set of closely spaced pin and ribbon to print it. All right, so this is the same technology used in typewriters. All right, so impact the page in the print character like typewriter. You may have seen the typewriters, right? In typewriters, they have a header, right? So the or we have a hammer, right? So that hammer is strike on the paper, right? Then it will print a character, right? So that technology is used in impact printers, right? There is a collision between hammer and the papers, right? So it says impact the page to print a character like a typewriter. So this is commonly used for printing invoices, purchase orders, and then in various locations, right? And then next one is thermal printers. Thermal printers. In here they print more cataly. Here the thing is this is very faster than the impact dot matrix printers, right? So this is very faster than the dot matrix printers. Then they are also smaller, right, and they consume less power, making them ideal for portable and retail applications. And nowadays these are very common in when you have say when you go to the say filling stations, right? So they have this kind of printers, right? So in voucher printing and then point of sales systems, right? They have this kind of thermal printing technology, right? Okay, and then in thinking that bus ticket, right? So when you have when you go to that what you call filling station, we have this kind of printers, and then actually they use this kind of printers in what you call printing the bus tickets, right? Okay, and then next one is floaters. This is also important, right? Floaters are important because actually So in other printing purposes, we don't need accurate what you call measurements, but we need accurate measurements in when you drawing, when you have what you call drawings, right? So like plan building drawings, right? In those cases, we need accurate measurements. So in plotters, they use a large scale printers that are used very accurate at reproducing line drawings, right? So they very accurate at reproducing line drawing. So this is the special point of plotters, right? So basically in drawings, in building or the building plan drawings, they need very accurate measurements. In that case, we can use plotters, right? In that case, we can use plotters. Commonly used for technical drawings such as engineering drawing or architecture blueprints, right? So due to this accurate reproducing line drawings, they use plotters for drawings, right? To take the printout of drawings, right? Okay, so that's about the printers, and the next output device is headphone. Headphone. So actually, the pair of small loudspeakers, or less commonly as a single speaker, and then this is held close to the user ears and connected to the single source, right? So you know these headphones, right? So I'm not going to explain these things, right? So that is another output device. Actually, here we use output device, especially output the sounds, right? And the next one is speakers. This is also output sounds, right? And then next one is multimedia projector, right? Actually, the projector simply project an image on a screen, right? So the multimedia projectors can be configured project a computer video signal, right? So this is designed for almost every application's level of quality and the size of audience, especially the size of audience, right? Okay, and then now this is very important part, that is input output port and the connectors, right? So I just what you call explain quickly input output devices, because you know those input output devices, but in here uh, we have to know what are the main ports and connectors, right, in computer, right? So what are the ports? What is port? Right? So port used to connect external devices to the computer. Basically, port is used to connect external devices to the computer. Connectors, actually connectors used to connect the external device to the computer through the port, right? So it used to connect the external device to the computer through the port, right? Port is used to connect the external device to the computer. Okay, so these are the main ports that we have, right? We call Ethernet port, parallel port, and then these kind of game ports, microphone and line in audio ports, and we have the serial port, COM1 and COM2 ports, and we have a USB port, say a PS2 ports. So these are called PS2 mouse and keyboard ports. So these are the main ports that we have. Then these ports can be categorized into several categories. We call serial port. The first one is serial, and then parallel ports, and then we have a universal serial bus port. We call USB ports, or PS2 ports, infrared ports, Bluetooth ports. Right. So likewise, we can categorize these ports into several categories. Right. So this is PS2 port. So this is PS2 port keyboard. So this is PS2 port for mouse, and these are USB ports. So this is Ethernet port. So this is serial port. This is a VGA port, right? So this is printer port, and then these are game ports, and these are audio video ports, or speaker, line in, and microphone ports. So likewise, we can categorize these ports into several categories, right? And then this is a serial ports, right? So let's take this category one by one. The first one is serial port. In serial ports, transfer data serially a bit in or out one at a time, right? And it takes longer time because data are transferred serially a bit in or out one at a time. Therefore, they take longer time. Necessary to send a start bit before each byte of data and stop it after each byte of data. Because so when data are transferred serially, right? So they have to specify this is the first bit or this is the starting bit and this is the stop bit in each data segment. All right. So otherwise the data cannot be identified properly. So usually this is known as communication port or COM port, right? ORS 22C port, right? Usually we use COM port, right? So in here come in the form of 9 pin or 15 pin male connectors, right? So in here they used to plug devices like keyboard, mouse or modem as well, right? So in serial port, so the main thing is data transfer serially and you have to specify starting bit and stop bit, right? So that's about the serial port execution. And the parallel port. In parallel port, it can send or receive 8 bits at a time, right? So that is data can be transferred parallelly, right? So it says transmit data parallelly. It comes with 24 pin female connectors. In serial ports, we have male connectors. In here, we have female connectors. So it's used to connect printers, CD drives, hard disk, right? So these are parallel port, right? So here we have female connectors, right? And then next one is universal serial bus, or we call USB port. So generally used for pen drives, scanners, cameras, even nowadays we use mouse, keyboard, printers as well, right? So this is USB port, you know this. And then next one is PS2 port. In earlier, keyboard and mouse are connected to the PS2 ports, right? So like this, right? Keyboard and mouse. And next one is IR port, infrared port, right? So here it send and receive IR or infrared signals, IR signals. It also transmit the transit and the transmitter and the receiver. All right. So here actually IR or the IR signal can be used in short distance, right? This is mainly used in TV remotes and music systems, right? So even we can use this signal system in our computers as well, right? Okay, and then we must have this kind of a receiver, right? And then Bluetooth. Bluetooth means the wireless protocol used to exchange data from fixed and mobile devices, right? So Bluetooth is a wireless protocol. This is used to exchange data from fixed and mobile devices, right? And this here uses radio frequency, right? So there should be a Bluetooth receiver, and then we can send Bluetooth signal, right? So basically we can use the Bluetooth signal for our mouse, right, and all those devices, right, and then transfer data from smartphone to the computer like this, right? Okay, so that's about the uh, what you call the ports of computer, the main types of ports, right? Okay, then I'll come to the actually that is the end of the hardware section, right? So at the beginning I mentioned in computer system there are main three components: hardware, software, and liveware, right? So then we come to the hardware, and then we discuss the central processing unit and the what you call the purpose of the CPU or processing unit and the main components of the CPU, and then I'll come to this what you call that memory characteristics, and then storage devices, input devices, output devices, and types of ports. Right. So there is a summary what we have discussed so far. Next part is software, and then what are the types of software that we have, right? Software, you know what are the software? So what is software? We discussed this, right? Collection of executable programs. You know what's meant by program? Program is a set of instruction. Then software means collection of executable programs with proper documentation and configuration files, right? So software can be categorized into system software, application software, and utility software. The application software can be further divided in package software and custom-made softwares, right? So system software. What is system software? Any software which control the operation of the computer, and the other types of software that run on the computer we call system software. What is system software? System software means the control the operation of the computer. By using system software, we can control the operation of the computer and the other types of software which are run on the computer. So by using system software, we can control the operation of the computer. At the same time, we can control the uh, other types of software which are running on the computer, right? So for example, operating system is system software, right? Compiler is system software. Assembler, translators, right? Actually those are related to the computer programming, right? So basically we know operating system is system software. Next one is application software. Application software. Actually, the application software means a type of program or the software that you use once the operating system has been loaded, right? So that is on top of the operating system, we can use application softwares. So programs designed to perform specific tasks, right? So in here, application software may be of two types: package software and custom-made softwares, right? Okay, let's take those two. Package software. Actually, package software means the software pre-written by professional programmers that are typically offered for sale. All right. So, for example, Office package. Right. So, in here we use Office package. Right. So, under the Office package we have a word processing application. So, this is useful for teachers, lecturers, doctors, and all those professionals. Right. Okay, all those applications, word processing, spreadsheet, database, presentation, all those are come under the Office package. So these applications are useful for various type of professions: lecturers, teachers, and then doctors, right? Even engineers, right? So this is for commonly used software, package software, right? And the next one is custom-made software. That is, programs written for specific purpose, and for a specific organization. So, for example, banking system. The banking system is useful for bankers and the customers. Those are not useful profession like teachers, right? Even they have, if they have an account in that particular bank, they can use it. But banking system is specifically used for banking purposes. All right. So, for example, student registration system. Student registration system useful for or used by the students and the teachers. Right. That is not useful for the doctors, lawyers, those professionals, because student registration system focus specific users, right? That is developed, designed, and developed for specific users, right? So those type of software are called custom made software. Custom made software. So general purpose software are called package software. Specific users, or the design and develop for specific users, we call custom made software, right? Custom made software. Okay, so that's about the two types of application software. The next one is utility software. Actually, the utility software means they carry out all the day-to-day tasks in maintaining a computer system and its data file, right? So, for example, virus guard or the screen servers, right? They utilize the computer system, right? So, assume if your computer is infected by the virus, right? Then all the functions are what you call act as a malfunctions, right? So by using the antivirus software, we can utilize your system, right? You can utilize the our day-to-day activities in a computer, right? So we can utilize the computer system. Okay, the next one is, what is the operating system? Now we have discussed system software, application software, and the utility software. System software, we know the system software can be used for control the operation of the computer and the other applications used in computer. And the next one is application software. Application software divide another two: package and custom made. The final one is utility software. So that's the summary of software types. Okay, then next go to the what is an operating system. What is an operating system? So operating system is the software program that enable the computer hardware to communicate and operate with the other software, right? So operating system is software program that enable the computer hardware to communicate and operate with the other software, right? That is, operating system act as an intermediator, right? Intermediate application between hardware and the user, hardware and the user, right? So now, so this is the evolution of Windows operating system. You know this, right? So this is the there are some here we have some Linux operating system, right, including the CentOS, Fedora, Ubuntu. Those are Linux platform, right? And then, you know, an operating system loaded to the main memory from the hard disk at what time? So when you switch on the computer, when you switch on the computer, operating system loaded to the main memory, that is RAM, from the hard disk, right? And the operating system does the following on the computer. So these are the main jobs of the operating system: the control the computer hardware, run the computer programs, organize the files. So those are the main job, the main functionality of the computer, right? And then a part of the operating system remain in the main memory until computer is turned off. That is the what you call the main part of the operating system is always stored in the uh, main memory, right? Okay, the kernel part of the actually the kernel part of the operating system stored in the main memory during the working time, right? Okay, and then the type of the user interface used in operating system. So actually user interfaces let user communicate with the computer. There are two types, right? We call command line interface and graphical user interface, CLI and GUI, right? So this is command line interface mode. In command line interface mode, uh, we have to keep in mind some commands. Then if you want to do particular thing, we have to use that particular command, right? So without command we can't do anything, right? So in here CLI user has have to use keyboard command to use the operating system. The user has to remember the commands, right? So at the beginning all the operating system were running on CLI mode, right? And even today some OS give CLI as a part of their system tools. Like in Linux operating system we have both CLI and GUI mode, right? Okay, and then this is a GUI of the operating system. Here this is a Windows 7, right? So in here Windows 7 GUI, so there are a lot of features are there. So we can use this graphical user interface to do the operations, right? Okay, and then in graphical user interface mode, right, it contains the graphics and icons, and it's all commonly navigated by the using a computer mouse and can be used to invoke command, right? Then the GUI was first used on Apple computers, right? And GUI is very easy to learn and use as a user-friendly manner, right? So many of the modern operating system come with GUIs, right? Especially Windows operating system, right? So in here we have some versions, right? So this is the evolution of Windows operating system, right? So some operating systems support both GUI and CLI mode. As I told earlier, in Linux operating system, we have a GUI mode, right, and the CLI mode as well, right? Okay. So this is the standard operating system model or the layered architecture, right? So on top of this layer, we have the hardware, that is general processing units and main memory, RAM, and input-output devices. On top of the hardware, right, we have a software, right? So in software, actually, uh, on top of the hardware, we have an operating system, right? On the operating system, we have a application software, right? On top of the operating system, we have an application software. That is operating system installed in the hardware, the main secondary storages, right? So inside the operating system or the even application software is stored in the secondary storages. Application software cannot be executing without operating system, right? Because the operating system is the system software which control the operation of the computer and the applications installed in that computer, right? Okay, so this is the layered architecture, and this is example. These are the sample software. So hardware, hard disk, motherboard, processor, and the main memory RAM. And then this is example for operating system Windows. So this is Windows XP, and then on top of Windows XP, we can install these applications. So peace package, virus guard, and then some programming languages. So here we have the Linux operating system, and in here also we have application softwares like OpenOffice, right? Ubuntu, Linux, antivirus, Java languages, programming language, right? Likewise, on top of the operating system, we can have application softwares. Okay, the next topic is computer backup and computer viruses. Computer backup and computer viruses, right? So why do we need computer backup, right? So first of all, let's say what is data backup. So why it is data backup is important. Actually, here important files are usually replicated in several places. So what is data backup and why it is needed? So first of all, the what is data backup? That is, important files are usually replicated or saved in several places. Simply we save copy of the file in several places. So why it is needed? Because we can have some uh, we have some kind of risk. Why or how? So we have to minimize the bad effect of hardware or software failure and virus infections, power failures, and unauthorized access to data, right? So we can minimize this bad effect by using data backups, right? So by using data backup, we can minimize the bad effect from these kind of things, right? So that's why we need data backups, all right? So now you know what is data backup and why is it needed, right? So there are a number of backup softwares, right? So backup software are used to data backup, right? So in our operating system, we have default backup softwares, right? Backup tools, right? In Windows XP, we have these backup tools, and in Windows 10, we have a file history option to backup, right? So let's see how can we use these options in practical sessions. And the backup program will skip currently using files, and backup up to data should be restored to be any use again, right? So this can generally be done using the same software that is used for backup or backing up, right? So backup file with extension. So this is one of basic or the popular extension is .bkf, right? Okay, then the backup media. So widely used backup media is so physically separated IDEO, these kind of drivers, right? Or we can use floppy disk, even zip disk, or the compact disk, right? Or uh, even the tapes, magnetic tapes, right? So magnetic tape also very popular in backup media, right? Okay, so that's about data backup. The next one is computer viruses, right? So I summarized this topic, that is virus, right? So I'm not going to discuss viruses in details, right? So actually viruses are the small programs that are written to affect the computer by altering the way it works. So there is a procedure there is a way of working in computer. By using computer viruses, right? They change this way, right? So that's why you say come program. Viruses are small program that written to affect the computer program by altering, that is changing the way it works, right? So different viruses are activated in different ways, right? The worst thing is that they can spread from one computer to another. That is the worst thing, right? So over the computer network or portable storages, they can spread out, spread. So it's better to use antivirus software and update regularly to uh, minimize the bad effect from the computer viruses, right? So the best thing is use the antivirus software and update regularly. That's also important, right? And then let's take the structure of the virus. Actually, the spreading module is there. That is the under the spreading module, they define the method of spreading the virus. And then payload module. Inside the payload module, they define the destructive action to be performed during the execution stage, right? There are two modules, spreading modules and payload module, right? And then types of viruses. First one is virus, and then Trojan horse, worm, right? So these are the main some types of viruses. And then antivirus. What is meant by antivirus? So antivirus is protective software designed to defend your computer against the malicious softwares, right? So I told you that antivirus is a utility software. Antivirus is utility software under the software categorization, right? So this is the end of this introduction part, right? So actually, basically, what we have discussed in here, first of all, I discuss some concept, data, information, and then what is ICT, and then what is computing, right? So those definitions are very important. And then the computer system, then computer systems can be categorized three main categories, right? Hardware, software, and liveware. And then what are the main types of computers, right? Frame, what you call supercomputers, personal computers, right? Mainframe computers, right? Those kind of types are there. And then we take hardware, software, and liveware, right? And then a hardware section, we mainly focus the central processing unit, how it is working. And then inside the processor, there are three main components, right? A control unit, ALU, and registers. And then the functionality of this each and every component, what CU doing, and what CU stand for, and then what is the purpose of ALU, what is the purpose of registers. And then we discuss fetch, decode, execute life cycle of fetch, decode, execute, right? So keep in mind those purpose, fetch, decode, execute, right? Sometimes you will be asked MCQ or the some yeah, MCQ questions from those concepts, fetch, decode, executing. And then memory units, right? So how to convert kilobytes to megabytes, megabyte to gigabyte. So if you are going to say 4 gigabytes, how to convert into the bytes, right? Likewise. And then we discuss main peripheral devices, input, output, and storage devices. In that case, keep in mind that hierarchy or the hierarchy of the storage, primary, secondary, and ternary, and then offline storage. And then the memory hierarchy, right? So how this memory hierarchy is there, right? So and then features of this memory hierarchy, right? So that is also important, right? And then the speed of the memory, right? So all those things are there, speed, and then the speed, size, right? And the cost, right? Speed, size, and cost, right? So it's better to uh, rewind all those things, right? The memory hierarchy. Uh, so you will be asked the questions from those sections, right? So keep in mind the yeah, this one, right? So how this is the features of this memory hierarchy, right? So I think it's better to what you call read this material again and again, and then when you're doing the practical session, right? So the key thing is you have to practice the things, right? So otherwise you can't have a what you call better skill performance in practical exams, right? Okay, thank you very much.